Hey biology students, this is Mr. Yago here. We're looking at section 2, the structure of the respiratory system, and we're going to break it up into two tracks. We have the upper respiratory tract and we have the lower respiratory tract. And note the organs that are involved in each. The upper respiratory tract is the nose, the nasal cavity, the paranasal sinuses, and the pharynx, which is the back of the throat. The lower respiratory tract deals with the larynx, which is going to be the voice box, the trachea, the bronchial tree, and the lungs. So if I were to give an area to break them apart, right at this point, you'd have your nose, your nasal cavity, your mouth, your pharynx is right there. That is all considered the upper respiratory tract. So if you have an upper respiratory tract infection, it's going to deal with the nose or the sinuses. If you have a lower respiratory tract issue, it's going to start right here in the larynx and then move down into the bronchial tree through the trachea and then into the lungs. So what I'm going to do next is go through some of the major anatomical features of the respiratory system. If you see in the top right, this is the general area that we are going to cover. We're starting up here in the nose and nasal cavity, which is a section of the body where air can enter. We have two ways, the nasal cavity or the mouth. The nose, as you can see depicted here, has bones and cartilage to support it. So actually, if you remember from the skeletal system, that bone actually stops back pretty far. And you can kind of feel that on the side of your nose. And whatever protrudes out forward to the tip of your nose is most likely going to be something called cartilage. And we've talked about various types of cartilage. This would probably be classified as elastic cartilage, which is very stretchy, also found in your ear. Now we have two openings, which are considered nostrils, and they are separate passageways at the beginning and then come together in the back of the throat. And as you can see here, we have this major bone here, which is called the septum. And it is a bone for a little bit, but it's also a big section of cartilage. So as I wrote down here, the septum is a thin wall made of cartilage and bone, and it divides the inside of the nose into two chambers. You will notice that, not in this picture, but inside of your nose, you're going to have some hairs, all right? And although they can be kind of a cosmetic, unsightly thing for most people, those nose hairs serve a very important purpose. Their job is to filter large particles that you breathe in. So if you breathe in through your nose, that is one of the very first things that will happen to that air is it's going to get filtered. This would be very similar to an air filter in a car, air filter in your furnace. Their job is to filter out large particles. So once air makes it through both of these cavities of the nose, we're going to make it into something called the nasal cavity. And that is a hollow space behind the nose, and that's pointed way back here. Now this is an anterior view. If we had a lateral view, you would notice that these two roads of either nostril come to a point that is shared, and that is the nasal cavity. If you have a deviated septum, that essentially means that the septum is bent one way, and what ends up happening usually is you struggle breathing out of one side of your nose, or you tend to get a lot of sinus headaches and sinus infections, but there's a lot that can be attributed to that. So if you do have a deviated septum, that's just a bend in this bone and cartilage, and you notice that it would probably cut one side off. So what's the benefit to breathing in through your nose? Well, we already mentioned one benefit, and that's going to be the fact that we have hairs that filter large particles. We do not have hairs in our mouth. Our mouth does not have the ability to filter air very well. Also, air is warmed when entering the nasal cavity. There is a lot of blood and a lot of organ sitting behind this nasal cavity, i.e. your brain. And that is a very deep portion of your body. So once air hits way back here, I'm going to point in this picture in the top right, but once air hits way back here, it's at the core of your body, and there's going to be a lot more heat back there. Okay, it's going to be a lot closer to that 98.6. So warm air tends to move quicker through the body. That's why, if you ever noticed, if you've ran in freezing cold air, it's very, very hard to breathe. Warm air, it's a lot easier to breathe. So that's one benefit. In addition to the hairs, we also have sticky mucus. We usually attribute to that being sick, but mucus actually traps a lot of particles which are pushed towards the pharynx and then swallowed. So that mucus is another line of defense, and that's not necessarily going to get those large particles, but it's going to do a better job of getting those smaller particles. And from there, we will swallow it down, which sounds kind of gross, but that's one way to ensure that the air you breathe is clean. So there is a major set of sinuses throughout the front portion of your face, and if you remember back from the skeletal system, sinus basically is an air cavity, and that's a space found within the maxillary, frontal, which is up here in green, ethmoid, and sphenoid bones. Okay, so we actually have four sets of sinuses. Three sets of sinuses that I consider. No, there's four. Sorry, we have the frontal, the ethmoid, and the maxillary, which are the three in the front, and then we have the sphenoid, which is very, very deep in the body. Okay, so we have three in the front and one that's very deep in the body. Essentially, what that does is it's going to reduce the weight of the skull, and it's actually a resonant chamber for voice, which I know sounds kind of weird, but it's going to actually give us a lot of our uniqueness to our voice, okay? Because everybody's vocal cords are the same, everybody has a tongue, but the shape of your skull, which will vary from person to person, is actually going to change a lot of that voice, especially with singers' voices. Now, what are some downsides to this? These air cavities can get infected, and I am an allergy sufferer and a definite sinus sufferer. Anytime we have a pressure change or a weather change, I feel it major in my frontal and my maxillary sinuses, and it's very, very painful. You'll notice that if those areas are pushed on, especially my frontal sinuses, I can feel my eyes kind of getting pushed on, blurs my vision, and usually what ends up happening is I get a massive headache. So although these sinuses reduce weight and help resonate the voice, they also can play a major role in some pain. So let's move out of the nasal cavity. We are going to start moving into the back of the throat, and we're going to be looking at two things, the pharynx and the larynx. Now, we could get super specific, and as you can see in this anatomy class, we could call these sections which are shaded the nasopharynx, the oropharynx, and the hypopharynx. But for this class, let's just say the pharynx. Sounds pretty easy. But the pharynx is essentially the back of the throat, mainly pointing to this area right in here. And that's an airspace behind the oral cavity, which is the mouth, and between the nasal cavity and the larynx. All right. Now the larynx is a little bit different. So if the pharynx is up in this location, the larynx is going to be way down here. Okay. So the pharynx is essentially the back of the throat and the back of the nasal cavity. The larynx is actually down the throat a little bit. And that's going to conduct air in and out of the trachea. So when you swallow food, I'm a food particle, I'm going to get chewed in the mouth and I'm going to go down. We have something called the epiglottis, which is going to prevent food from going down the windpipe. But notice that these pipes run parallel. Esophagus is actually deep, whereas the larynx and the trachea are going to be superficial to that esophagus. It'll also house the vocal cords. So your vocal cords are found in the larynx, and you'll probably remember looking at them when you saw the Incredible Human Machine video, which we had Steven Tyler, lead singer for Aerosmith, and we showed a little endoscope going down there. But that will produce sound. You push air over it, air is going to come out of the lungs, and it's going to vibrate when they are contracted and when they are relaxed. So it's going to push air over it. So that's going to allow us to change pitch, which is going to be the highness and lowness in our voice, and essentially give us the ability to speak. So if your vocal cords were to ever be taken out, your language would be immediately gone. If you suffer from something called laryngitis, that's a mucous membrane that supports this area, becomes very swollen, and actually prevents the vocal cords from vibrating. So the mucus would cause some inflammation. Funny story about laryngitis. At Green Bay when I was in college, we had a professor who was old as dirt. Guy had to be probably 75 or 80. And he had every single lecture on tape. And it was terrible. If we hit a spot where his laryngitis would flare up, he would literally walk in with his tape recorder, sit down, smile at us, and put his finger on the play button. And he would go up to the board and he'd take notes as his voice was playing out of this. Man, worst 45 minutes of my life. But that would definitely be a topic for our respiratory system. So I mentioned this structure called the epiglottis in the previous slide. Location is right here, and it's kind of like a trapdoor. It has a very important job. It's a flap-like structure that stands upright and allows air to enter the larynx during swallowing, and it's pressed downward. So as you swallow, you kind of notice your Adam's apple move up and down. Well, when you do that, that Adam's apple actually goes up. So if you I'm swallowing right now just so I can demonstrate it, but if you swallow, you can feel that Adam's apple go up, and as that goes up, this door actually goes down. So think a little bit about why that's important. So when food goes down here, if you had food go right down into this pipe right here, we sometimes call it going down the wrong tube, you wouldn't be able to breathe. That would be considered choking. You would want to be able to get some Heimlich maneuver to get that expelled. But this epiglottis has a very, very important job. So every time that you swallow, feel your Adam's apple, it's going to move up, and as that moves up, that epiglottis will shut. And food will essentially be bypassed into the esophagus instead of down there. So it has a very, very important job, and its job is to prevent food from entering air passageways. Does it do its job every time? No. Sometimes we choke on things. Usually when we swallow liquid, sometimes the glottis isn't always closed and we get a little liquid and then we cough it up. But our bodies are innately wired so that if something happens, we get something you're not supposed to be, we immediately start to cough. And a cough is essentially your body trying to expel something out of your lungs. So, very important structure, epiglottis. It's going to prevent us from swallowing things down the wrong tube. All right, we are almost to the promised land. We're going to start with the trachea here. Different view. If you look in the top right, we are now up in this area right here. We've moved past the epiglottis, but here's the larynx, which we just mentioned before. This would be your Adam's apple. Once we have opened the epiglottis and air has gone into the trachea, you'll notice that it is a tube with some tracheal cartilage rings that wrap around this. Now, cartilage is very strong, and you can actually find this area just above your collarbone and kind of move your finger up and down and feel those cartilaginous rings. Okay, so take a second to do that. It's always good to immediately look at the anatomy and be able to use your own body as a means to understand. But feel those tracheal rings. It's very, very strong. Now think about why you'd want that to happen. This windpipe is very flexible, and it is made of hyaline cartilage. But what that cartilage does is it's going to prevent it from collapsing, and that's the function that I really want you guys to focus on. That cartilage is strong yet flexible, and essentially what it's going to do is prevent that tube from closing. All right, that's very, very important. So if here's the main branch of the trachea, once that hits a fork in the road, we're going to start to split off because we have two lungs. We have a right and a left lung. And we're going to hit something called the primary bronchi. And that's located here and here, and that's the fork in the road. So as air moves down the trachea, it's going to either branch to the right or the left, and that's going to lead us to the air sacs in the lungs. And this is where our major goal of exchanging gases are exchanged between alveoli. Sorry, that I is cut off there. It should be alveoli. And we're going to look at that on the next slide in terms of how do we exchange this air we breathe with the blood. All right, so last slide in this section 2 on structure, and a big slide, very, very important. We're going to start with the lung. So we have entered air through the trachea to the primary bronchi, and now we are basically expelling that air out into the lungs. Lungs are very soft, very spongy, and they're actually kind of cone-shaped. And inside, we have something called the pleural cavity, something we learned the very first week of school. And we have fluid in there. Notice that is serose fluid. One of the major points that I talked about serose is that was the outer portion of our alimentary canal. And the major job of that is to prevent friction between other organs. Well, this same fluid is found in the lungs. And that is all over the inner surface of the lungs. And what that's going to do is it's going to prevent the lung from collapsing. If we had mucus in there, and that is a very common thing if you have a cold, or if you have any type of infection in the lungs like pneumonia, those lungs, when you breathe, if there was mucus, they would actually stick together. Okay, and that's a major problem. That would be considered a collapsed lung. It's no longer functioning how it should be. So that Serose fluid is a major anatomical advantage and a major function in preventing the lung from collapsing. Definitely would want to know that. So, how does this whole process of exchanging gases occur? Well, it relies on something called the alveoli. And here's a blown up picture of what that looks like. I want you to notice right off the bat that we have capillaries and we have a pulmonary vein and the pulmonary artery. You guys know that already. So these alveolar sacs are very similar to bunches of grapes, and they are going to be, we're zooming in. This picture right here is actually zoomed in from a really tiny spot right here, but these are all over all of these branches inside of your lungs. Why circular? Well, you should probably think about surface area. So they are composed of epithelial tissue, so it's a soft tissue, and it's covered in something called surfactant, which is very similar to serose fluid. And surfactant is going to prevent these alveoli from collapsing. And you will notice that these little grapes of alveoli are surrounded by capillaries, and that is the smallest and thinnest blood vessel in the body. So the process of diffusion is going to allow us to exchange these gases. So every time you take in a breath of air, we are going to exchange oxygen and give off CO2, and that's how this whole process is going to occur. So all of this gas exchange is happening at a very, very zoomed in level, and it deals with the alveoli. And the reason it can do that is because we have capillaries, which are very, very thin. We have surfactant, which is preventing collapsing, and we have a very spongy tissue and epithelial that can allow these alveoli to function. All right, that's everything from this section. If you got any questions, please let me know. These notes on section 2 are very, very important for you to understand the rest of the sections. As we move forward to section 3, we're going to focus on our major physiological process, and that's going to be the mechanism of breathing. All right, that's all I got for this one. We'll see you later. Yago out.